In this video, we talk about the marginal cost, the marginal revenue, and the marginal profit. Let's start with the marginal cost. We first define the total cost. The total cost of a number of X items is given by C of X equals variable cost plus fixed cost. So it consists of two parts: variable cost and fixed cost. For example, if this is linear, then we write mx plus b. This is the variable cost and this is the constant cost. Now the variable cost here, an example of a variable cost, the coffee shop manager will have to hire more workers if number of customers increases. And by fixed cost, we mean expenses that are independent of the level of goods of service produced by the business. For example, monthly rent for a coffee shop, or monthly rent for basic phone. These are constants or fixed costs. And sometimes this is visualized as follows. We have here the fixed cost, and here we have variable cost, and here the total cost. Now, what is a marginal cost? Now, by marginal cost, we mean the rate of change. That means we can talk about derivative if we are talking about rate of change. So the rate of change of the total cost that arises when the quantity produced incremented by 1 unit, and this is very important, incremented by 1 unit. So in this case, we may write the marginal cost as the change in C, the cost, over the change in quantity, X. Over change in quantity. Okay. Now here we have an example, and from in this example I'll show you what we mean by the rate of change of the total cost. So if the cost in dollars to manufacture a portable music player is given by this function, where X is number of music players manufactured, we first find the marginal cost function. Now before we find the marginal cost function, let me talk more about the marginal cost. Here we define it as rate of change, and that means we can talk about derivative here. So for example, here if we have the total cost function given by this, and we have a specific value here, let's say 10,000, and 10,001 here, 10,001 is here. 10,001, that means this is incremented by 1 unit, and the quantity produced incremented by 1 unit, and that means the difference between them is very small, just 1 unit. So if we draw a tangent line here, since those are very close to each other, those two values 10,000 and 10,001, we imagine that we have a tangent line. So the tangent line here that touches the curve of Cx at the image of 10,000 is the slope of this, of the tangent line, is given by the derivative of the cost function c prime of x, and we can think of this as two distances here. This is on x-axis, the horizontal distance is just 1 unit, and the vertical one is the change on c. We don't know it exactly, so the rate of change here is dc over dx, but dx is just the horizontal change is 1, so dc delta c over 1. So this is the derivative. This can be approximated by the derivative of the function at the value x. So that's what we mean by rate of change. Rate of change, or the slope of the tangent line, is the derivative. So that's the marginal cost. Okay, so for the first part, we want to find the marginal cost. So all what we need to do is to find the first derivative of this function. So first derivative of this function is 20, because derivative of the constant is 0. Derivative of 20x is 20 minus derivative of this constant times x squared. Derivative of x squared is 2x, and we multiply it by this constant. This gives 0.0002x. Now this is the marginal cost function. Now we want to estimate the cost of manufacturing 50,000 first music players. So if this is the 50,000, we have here 50,001, and as we described before, this is the tangent line. The slope, the tangent line, this represents the marginal cost, and the blue one is the cost function c of x given by this rule. So we want to find the derivative at this point. Now here the derivative can be approximated by c of x plus h minus c of x over h, where h is the same as delta x, the change on x, but the change on x is just 1 unit, as we described here, just 1 unit. That means this is c of x plus 1 minus c of x over 1. Now if we want to find c prime, if we want to estimate, just estimation, we want to estimate the cost of manufacturing 50,000 first music player, that means we can find the derivative at 50,000, because those are very close to each other, and that's just the tangent line touches the curve at that point. So the derivative here is c of, we just substitute the value of x, this is x, so it's 50,001 minus c of 50,000. This represents the cost of the 50,000 first music player. So the derivative here can be approximated as 9.9998, or we just find the derivative at, okay, so this should give us $10, but if we want to, this is just an estimate, but if we want to find the exact value for a derivative at 50,001, we need to plug this into the derivative, so we get 20 minus 0.0002 times 50,001, and that gives us 9.9998. And as we can see, this derivative is just an approximation of the derivative at 50,001. So this is just an estimate, but this is exact. So this is the estimate. So we can add some description to the answer 10. This is a good approximation for the cost of producing 50,000 first music players or player. Okay, so this is exact value and this is just an estimate. Sorry, this is, let me write it here. This is estimate and this is exact. Okay, now let's take another example. So from now on, when we are asked to find the marginal cost, we just find the derivative of the function. So here we want to find the marginal costs at the production level of 100 items if the cost function is given by this. So all what we need to do is to find the derivative. Derivative of the constant is 0 plus derivative of 20x is 20 minus what is derivative of 1000 over x. So you can apply the quotient rule. The denominator times derivative of the numerator. The numerator is constant, so derivative is 0. Minus numerator times derivative of the denominator. Derivative of x is 1 all over denominator squared. So this is 0. We get negative 1000 over x squared. So we can write it here. Minus 1000 over x squared. Minus minus is plus. Okay. Now we want to find the derivative at, or the marginal cost at level 100. So we just plug 100 here. So we have 20 minus 1000 over 100 squared. This is 20 minus 1000 over 10,000. Cancel 3 zeros. We get 20 minus 0.1, and that's $19.9. Okay, now we have other concepts like marginal revenue. By marginal revenue we mean rate of change of revenue with respect to number of items, and that is r prime of x. So if we find the revenue function, then we just find the derivative to find the marginal revenue. The marginal profit is the rate of change, that means derivative of profit with respect to number of items. This means we find the p, the function p, the profit function, and then we derive it or differentiate it. So let's take an example. Here John operates an iPad refurbishing service. The costs of refurbishing X iPads in a month is calculated to be C of x equals 0.25x squared plus 40x plus $1,000. Now John charges customers $80 per iPad for the work. We want to calculate the marginal revenue and the marginal profit functions and then interpret the result. So here we first find the revenue to find the marginal. So the revenue is the price times quantity. The price is 80. The quantity is x. Number of quantities is x. This is R of x. Now to find the marginal revenue, we just find the derivative of this, which is 80. Now let's find the profit function or the marginal profit. So first we start with the profit function. So profit is equal to revenue minus the cost. So the profit is R of x minus C of x. R of x is 80x from here minus C of x. This is given here. It's 0.25 x squared plus 40x plus 1000. And when we simplify, we get negative 0.25 x squared plus 40x minus 1000. So the marginal revenue is R prime of x, which equal to 80. So this is the approximate revenue from refurbishing one more item. This is how we interpret it. The marginal profit is P prime of x, and this is negative. We need to differentiate this function. This is P of x. We want to find derivative of this. This is negative 0.5x plus 40. And this can be interpreted as the approximate profit from refurbishing one more item. Okay, now if X iPads have been refurbished a month, then you will earn a revenue of $800. So if X iPad have been refurbished a month, then John will earn a revenue of $800. This is constant, and make a profit of approximately negative 0.5x plus 40, and this depends on x. If you ask me about 10 iPads refurbished a month, then we just plug 10 into this rule or formula or expression. So it decreases as x increases. The profit decreases as X increases. Okay. Now part B, we want to find R, the revenue, P, the profit, R prime, the marginal revenue, P prime, the marginal profit, if John has refurbished 20 units this month. So let's find these functions and these values. We know that R of X is 80X and R prime of X equals 80. So R of 20, refurbishing 20 units, this gives 80 times 20, and this is 0016, $1,600. Now R prime of 20, since R prime is constant, we still have 80. What about P of X? P of X is negative 0.25x squared plus 40x minus 1000. We obtained it here. So we want to find, to plug 20 into this formula. So we get negative 0.25 times 20 squared plus 40 times 20 minus 1000. And using the calculator we get negative $300. Now we find P prime of X. P prime of X is negative 0.5x plus 40, and then we plug 20 into this function. We get negative 0.5 times 20 plus 40, and this gives us $30 per unit. $30 per unit. The part C, for which value of X the marginal profit is 0. This means we are talking about marginal profit. Marginal profit is P prime of X. We want to find the value of X that makes this equal to 0. So that means we need to solve the equation. What is P prime of X? P prime of X is here, is negative 0.5x plus 40 equal to 0, and then we solve for X. So let's bring this to the right hand side. We get 40 equals positive 0.5x, and then we divide both sides by 0.5 to get X equals 40 over 1/2, that's 80. So 80 iPads. So if John refurbished 80 iPads in a month, refurbishing one more will get John will get him 0 additional profit. And we can visualize this by graphing this function. So this is P of X. This is the graph of the function P of X. And here we have 40. In the middle we have 80. And here we have 120. This is X and this is P of X. At 80 we have a maximum point. As we can see, the derivative, the tangent line is horizontal. That means the derivative of P is equal to 0. Derivative is the slope of the tangent line, and the tangent line has slope 0 at this point. Now the last concept in this section is the average cost. The average cost is given by this formula. C bar of X, this is the average cost, is equal to the total cost divided by X. We just divide that function by X. For example, suppose that the cost to manufacture watches is given by this function C of X. where X is between 0 and 400, where X is number of watches manufactured in a day. We want to find the average costs per watch if 200 watches are manufactured a day. So we want to find average costs. Okay. And then in part B, we want to find a formula for the average cost if X watches are manufactured in a day. Let's start here. Let's start from B, and then we do part A by just plugging this value. So if we start from B, we want to find a formula for the average costs. The average cost, C bar of X, is C of X over X. So we just divide C of X by X. This gives 1000 over X plus 125, the second term, minus 0.6x, because we divided X squared by X. That means we cancel 1x. We get just 1x, plus 0.001x squared, because we divided X squared by X. That means we are left with X squared. So this is the average cost function. Now let's back to part A. Part A, we want to find the average costs at if 200 watches are manufactured. That means we only need to substitute this here into C bar. This gives us 1000 over 200 plus 125 minus 0.6 times 200 plus 0.001 times 200 squared. And if you use a calculator, you get $50 per watch.